Set, go. Here we are. All right, we pick up with, operations with complex numbers. So write these two things down. Z sub 1 is R sub 1 times cosine of theta sub 1 plus I sine of theta sub 1. And Z sub 2 is R sub 2 times cosine of theta sub 2 plus I sine of theta sub 2. So we're just stating that we have two complex numbers. We're placing them both in trigonometric form. Once we place them in a trigonometric form, the question is, how do we do operations with them? And right now what I'm going to show you is how do we multiply them and how do we divide them. If we want to add them, we would never place them in a trigonometric form anyway. We would just add them. It's very easy. Just combine like terms. So if you're going to multiply them, here's what you do. Z sub 1 times Z sub 2. And this is the easy part of the lesson. Z sub 1 times Z sub 2, we would take the two R values and multiply them together. So R1 times R2. And then the theta values, we add them together. Would anybody like to guess how that changes if we were to divide them? Subtract what? The thetas, yep. And how about the R values? Yeah. So Z1 divided by Z sub 2 is R1 divided. Good luck, guys. Go get a victory. Cosine of theta sub 1 minus theta sub 2 plus I sine of theta sub 1 minus theta sub 2. All good? That's the formula, and that's what I would make sure that you write down in your notes, which you get to have on the test, which is your responsibility to put together in the way and shape and form that you want. Okay? Master texter. Oh, it's okay. I know what you're doing right now. Okay, anyway, here we go. So now what we're going to do is it says find Z1 times Z2 and Z1 divided by Z2. So Z1 times Z2. And we know that Z1 is 2 cosine of pi over 4 plus I sine of pi over 4. And Z sub 2 is 5 cosine of pi over 3 plus I sine of pi over 3. Now, my good friend Casey said that she was kind of struggling with how to turn it into that form, right? We're going to do that today in 3 times. So you're going to see that repeated. But right now, they're already in trigonometric form. What I want to do is I want to now multiply them. So what happens to the 2 and the 5? Times them, I get 10. Times cosine of something plus I sine of something. What's that something? Yeah, what's pi over 4 plus pi over 3? What's the common denominator? 12, so this would be 3 pi over 12, and this would be 4 pi over 12. Yeah, 7 pi over 12. That's it. Nope, you don't have to do anything. Now I'll do divide. Z sub 1 divided by Z sub 2. What happens to 2 and the 5? 2/5 times cosine of 3 pi over 12 minus 4 pi over 12 is negative pi over 12. No, we're not done. Why? Yeah, you can't have negatives. You don't want negative angles. What's cosine of a negative? Yeah, it's positive. So 2 over 5 cosine of positive pi over 12. Well, that was easy. And what do we do with the sine of negative pi over 12? Yeah, so it's minus I sine pi over 12. Because from last unit, we learned that cosine is an even function. You learned that cosine of negative x is always equal to cosine of x. Whereas sine of negative x is equal to negative sine of x. Now, I know that the day we covered that, Brody, I know that you were wrestling that day. So, but that was on that big sheet of notes that we had. So for cosine and secant, the negative goes away. For all the others, the negative comes out front. No, but you can't just square that. You don't have another I here. So negative I is not I squared, and negative I is not negative 1. Negative I is negative I. Good thought, but it doesn't work. Okay, so along came a dude, and his name was DeMoivre, and he was a great mathematician, and he put forth a really cool idea, and that was the following. If you have a complex number z, which is, and written in trigonometric form, as r times the cosine of theta plus I sine of theta, he said, what if you want to take that z value and you want to raise it to the nth power? So I'm going to multiply it by itself n times. I'm going to multiply it by itself n times. So you have r times cosine of theta plus I sine of theta times r times cosine of theta plus I sine of theta. Multiply that over and over and over and over again. So we just learned about multiplication, right? So if we multiply it over and over and over again, what's going to happen to the r? How many times do you multiply the r? You multiply it n times, right? So what is r times r times r times r? N times. R to the nth power. Z expresses the entire number. Now, the theta values, you add them up. So I'm going to do theta plus theta plus theta plus theta n times. So what do I get? N times theta. So it's cosine of n times theta. Well, just so you understand what's the angle and what isn't. You can. Freedom of choice. America, free country. Do what you want. Okay. Yep. So, I remember this problem on your last test. I warned you that was an IDK problem, where it said, reduce it to first power in terms of cosine. Now, nobody wrote IDK. Thank you very much. But there still were some 0 out of 4s and 1 out of 4s, okay? Do you remember when we had sine of 2x, cosine of 2x, and tangent 2x? And I warned you that was an IDK problem. And again, nobody wrote, whoop, that's kind of ugly, IDK. Nobody wrote IDK, but there were some 0 out of 4s, 1 out of 4s, so on and so forth. So we want to try to avoid those 0 out of 4s, 1 out of 4 type problems. This is a 0 out of 4, 1 out of 4 type problem. This is an IDK type problem. It doesn't have to be. Tomorrow's, totally get it. Tomorrow's, very difficult, okay? Unless you're really engaged and really focused and work hard through it, you're not going to get tomorrow. I'll set it right out there for you, okay? You got to really want to get tomorrow's. You got to have your A game, be ready to go. We're going to find the nth roots of complex numbers. It says instead of raising it to a power, say n, we're going to raise it to the 1 over n power. And it's a lot more challenging, okay? But today's, everybody could get today's. Yes. So here's what we do. We first place it into trigonometric form. So this is where Casey was having some troubles, okay? So I want to put this into r sine of theta, cosine of theta form. Thank you. And as they sit together, you guys are sitting together. As they are right here, I've got r, and then I've got theta. How do I find r? What did we learn yesterday? Pythagorean theorem, square root of a squared plus b squared. 1/4 plus 1/4, which is 2/4 or a half. I get square root of a half. Now I'm going to raise 1/2 to the 1/2 power. Square root of a half. I raise 1/2 to the 1/2 power, and you'll see why in a little bit. Everybody okay with that? All right. Theta, how do I find theta? I set up tangent of theta is. How do I set up tangent of theta? Yeah, b over a, which is half over half, which is 1. So it's positive. Where's tangent positive? First and third. Am I in the first quadrant or the third quadrant? If you plot that complex point, it is in the first quadrant. Very good. Inverse. 1 on your calculator, you get 45. Change it into radians. Pi over 4. And so therefore, we have 1/2 to the 1/2 power times the cosine of pi over 4 plus I sine of pi over 4. Callie sitters, tell me, when you were experiencing trouble placing these into complex form, which part were you struggling with? Getting the angle. Do you see how we did that? Okay. Do you see how we came up with 1? Do you see how I knew it was the first quadrant and not the third? I knew it was the first because if you plot this point, 1/2, 1/2, that brings you to the third quadrant. I'm sorry, the first quadrant. So then on my calculator, I inverse 1 and I get 45 degrees. So that means this is a 45-degree angle. I change that to radians, pi over 4, Ella. I take b and divide it by a. 1/2 divided by 1/2 is 1. We good? Okay. Negative b over 2a. That's vertex for a parabola. All right, so here's what I got. I've just placed it into trigonometric form. That's what we did yesterday. What power do I want to take it to? The 10th power. So look what I have here. I have 1/2 to the 1/2 power to the 10th power. What do I do to the exponents when I'm taking a power to a power? Multiply. And so you get 1/2 to the 5th. So it's 1/2 to the 5th power then. Times cosine of, what do we do to the angles? Pi over 4 times 10, so 10 pi over 4. Yep. Now we're going to do some simplifying. First of all, we can simplify 1/2 to the 5th power. Second of all, you can't leave an angle that's greater than 2 pi. And so we'll show you how to simplify that, okay? 1 to the 5th power is 1. 2 to the 5th power is 32. Good job. Cosine of, Braden said 5 pi over 2. I sine of 5 pi over 2. Is 5 pi over 2 greater than 2 pi? It is. You can't have an angle greater than 2 pi expressed at this point. It needs to be less than 2 pi. So, just because. It's not a good enough answer. So, put 2 pi so that it has a denominator of 2. What is 2 pi renamed so it has a denominator of 2? 4 pi over 2. So all I'm going to do is I'm going to take this 5 pi over 2 and subtract 2 pi or 4 pi 2 off of it. Take 5 pi over 2 and subtract 4 pi 2 off of it. What do you get? So I have 1 over 32 times the cosine of pi over 2 plus I sine of pi over 2. This is what we call trigonometric form for your answer. Because I'm a jerk, you have to place it also in a complex form on your test and your homework. Now that sounds bad. It's really no big deal at all, and I'll show you. You have 1 over 32 times, what is the cosine of pi over 2, or 90 degrees? 0. What's the sine of pi over 2, or 90 degrees? 1, so you just get I. So if I distribute the 1 over 32 through, I get 1 over 32 I. That is the complex form of your answer. So I need both this answer, reduced trigonometric form, and I need this answer, which is complex form. So what did we learn? We learned that if you were to take 1/2 plus 1/2 I and multiply it out 10 times, it would come out to be 1 over 32 I. I dare you to do that, to multiply this out 10 times and see if you come up with that. No? You can't use your calculator. Stop it. All right, here we go. Whatever. Whatever. All right, we got 2 more. Okay? Get our A game on. Make sure we do a good job. Okay? 1 plus root of 3 I. The I should actually be sitting in the root of 3, but I didn't write it quite right. I'm sorry about that. Okay? I'm going to raise that to the 20th power. First, I'm going to put it into trigonometric form. So I got R and I got theta. Okay? How do I find R? Which is 2. Look at that. Nice and easy. Interesting. All right. And now, how do we find theta? Tangent theta is root of 3 over 1. Tangent is positive. In which quadrants is tangent positive? First and third. Are we in the first quadrant or the third quadrant? We're in the first quadrant. Inverse the root of 3 and you get 60. Convert 60 to radians. Pi over 3. Great. So now I have 2 times the cosine of pi over 3 plus I sine of pi over 3. So all I've done is what we did yesterday, which is put it into trigonometric form. What do I now need to do to it? Raise it to the 20th power. Okay? So what do I do to the 2? Yep, so it's 2 to the 20th, which is a really big number. Once you get over 10,000, don't even worry about writing it down, okay? It's like a million, which is a lot. Which, like, well, I guess in terms of national debt, it's actually a little bit, but for most people, it's a lot. National debt, very small, very small. Race to 1 quadrillion, 2067. We're on our way. We'll be there. I gave you guys a problem, right? When we did exponential growth right before the first semester, you guys calculated based on our, since 1920 and our spendings, we are predicted to hit 1 quadrillion in debt in 2067. I will be like 87 years old, and I want to live to see it. We all got to hope for something, you know what I mean? And, you know what I mean? I guess it'll be, well, see, I'm in a win-win situation. If we hit 1 quadrillion, I'll say yes. Like, students now know what comes after a trillion. Like, it's quadrillion, you know what I mean? Like, for a lot of time, people were like, what's after a billion? Well, just wait till we spend enough money, then we'll learn. So, so now we'll know what 1 quadrillion is. But if we don't hit it, that means we've actually reduced our spending, which I don't see how that's possible because nobody's done it in 100 years. But implode? Yes. I think that there's going to come the time in the world where there's just going to say everybody has to press like reset on their debt calculation, and every country starts back over at like zero. Say, okay, you know what I mean? I don't know. Whatever. So heptillion would be 7. So 6 sextillion. Yep. But people don't say it anymore. They say millions of billions or millions of trillions or billions of trillions. So that it's, yeah. So anyway, and there's actually theories of like large numbers. So you can like look up Graham's number, which is ridiculously large. It's like Googleplex, things like that. And so anyway, okay, let's move on. All right. So what do we do with the angles? We times them. Cosine of 20 pi over 3 plus I sine of 20 pi over 3. You guys, I get people that get to the test and they're like, well, I didn't know what to do with the angle. What do you mean you didn't know what to do with the angle? Multiply by 20. Like, just put the 20 there. Because it's times 20 over 1. Okay. All right. So now, oh boy, is that bigger than 2 pi? Oh, yeah. Yeah, you betcha. So now we're going to go here, and we're going to rewrite this here 2 pi so it has a denominator of 3. What would that be? 6 pi over 3. So if I take 20 pi over 3 and I subtract 6 pi over 3, what do you get? 14 pi over 3. Is that still too big? So subtract 6 pi again, and you get 8 pi over 3. Subtract it again. 2 pi over 3. Because you're way too smart. So keep on subtracting until you turn out good. So that is trigonometric form. I have no idea. I just work here. Doesn't mean they tell me anything. So that's trigonometric form. Now I'm going to place it in a complex form. So I have 2 to the 20th times, what's the cosine of 2 pi over 3? Uh-oh. Got to go back to this guy. That's my terminal point, right? So which one's cosine? -1/2. Okay, I've got that. And there's one more thing we can do to simplify this. So I know it's going to look confusing, but if I take 2 to the 20th over 1 and multiply it by 1 over 2, okay? Forget about the negative. I multiply it by 1/2. I get 2 to the 20th over 2 to the 1st, right? So it's 2 to the 19th. You subtract your exponents, right? X to the 20th over x to the 19th, right? So, which part? So, okay, so this will simplify to -2 to the 19th plus 2 to the 19th times I roots of 3. Now, the book might leave it like that, or it might leave it like 2 to the 19th times -1 plus I roots of 3. I don't know how the book will leave it. What I can tell you is that this is complex form, and I would select I would allow either one of those. And for trigonometric form, that's what I would want. How are we feeling there, Tristan? On a level of 1 to 10 for excitement, where would you rank your excitement right now? -4? What? Oh my gosh. Ugh. Okay. So, YouTube, I know you guys can argue with my class is more excited that this is the last problem than they are about what we're doing. I gotta try to I'm not conveying to you why it's so amazing, am I? You guys, we would multiply this out 100 times. 100 times. Let's do it. Well, let's do it in 3 minutes. Somebody want to time us? Set the timer. See how quickly we can do it. Lauren, tell me when we're ready. Okay, Trish, I knew she had her phone out. Yep. Oh, okay. I gotta find R. Square root of. So, 2. Good. Theta. I got tangent of theta is -1. Where's tangent negative? Second and fourth. Ah! They said third. I'm sorry. They don't know what they're doing. All right, so great. So if we inverse 1, what's the angle? First of all, which quadrant are we in? Second or fourth? We're in the fourth. Inverse 1, and you get 45. So what's that angle in the fourth quadrant as a reference angle 45? 315. Convert 315 to radians. 7 power 4. Jill Peterson, go. Yo. I got the root of 2 times the cosine of 7 pi over 4 plus I sine of 7 pi over 4. Gonna raise that to what power? 100, are you kidding? Your teacher must be nuts. So that's 2 to the 1/2 to the 100th power. 2 to the 1/2 to the 100th power. To the 50th. Cosine of 700 pi over 4 plus I sine of 700 pi. Is 700 divisible by 4? Yeah, 100 is divisible by 4, so 700 better be divisible by 4. 175. We got cosine of 175 pi plus I sine of 175 pi. Uh-oh, is 175 pi bigger than 2 pi? Yeah. Yes, B. Rodden sees it. Why is it just pi? Yeah, you got it. It's odd. So look at this. This is 0. This is 1 pi. Then I get to 2 pi. Then I get to 3 pi. Then I get to 4 pi.
We only have 3 minutes.
Okay, just stop rushing me. So you see that all the odd pi's are over here?
Yeah.
So that means it's just pi. So 2 to the 50th times the cosine of pi plus I sine of pi. That's trigonometric form. Let's go to complex form. What's the cosine of pi? -1. What's the sine of pi? 0. So -2 to the 50th power. Done. We had 8 seconds left, YouTube. We did it in 2 minutes, 52 seconds. In 2 minutes and 52 seconds, we took 1 minus I, raised it to the 100th power, and we end up getting 2 to the 50th, and it's negative. That brain explosion. Unbelievable. Oh, the power of complex numbers. What? That's, no, you didn't. No, it's totally wrong. No, look, this is wrong. He did his, and he came up with 1.12. That's wrong. You're wrong. Don't make fun of my speech impediment. I don't make fun of your lack of math abilities. Whoa! Whoa! Oh! Oh, all of a sudden, I'm going to get a complaint. All right, what? I'm just joking. Okay. All right. I'll give you the assignment as long as somebody can say, that was impressive, Mr. Gintz.
That was impressive. That we did it under 3 months. We just don't tell the joke.
Extra credit and your ACT stuff is due on Thursday. Okay. Extra credit was to do the ACT extension. Yep. 60 problems, 60 minutes. Score it. Just hold on. Everybody good with the assignment? All right, I'll press stop.